Hello students, now our topic is on division properties of exponents. To divide two powers with the same base, subtract their exponents. And when you're getting the power of a quotient for any integer m and any real numbers a and b, you just have to multiply or distribute the power. And if they're the same base, then you subtract their powers. Let's go ahead and discuss the first example. A to the fourth b to the seventh divided by a to the first power b to the second power. If you've already watched the video on multiplication properties of exponents, we have to add their exponents when you're multiplying power numbers. And this time, since we are dividing power numbers, we have to subtract their exponents. The same base a to the fourth and the a to the first power, you have to subtract their exponents or powers. So it will become a to the third power. Do the same thing with the b variable. So our final answer is a to the third, b to the fifth. The second example, 2a to the third power, b to the fifth power divided by 3b to the second power, close parenthesis, third power. Since there is a parenthesis between powers, therefore we will have to multiply this power outside to each of the power inside, including the power of that coefficient 2. 2 to the third power. The a will be a to the ninth power. The b to the fifth power will be b to the 15th power. Same thing with the denominator. b to the sixth power. Now we can further simplify. 2 to the third power is 8. 3 to the third power is 27. Since there's no a variable at the bottom or denominator area, therefore we just put a to the ninth power by the 8. Now divide b to the 15th power divided by b to the sixth power. Subtract their exponents or powers. Since the power of b is positive 9, therefore, it will remain on the top of our fraction. And our final answer is 8a to the ninth power, b to the ninth power, divided by 27. 5 to the fifth power divided by 5 to the second power. To further explain what's going on here, why do we have to subtract the exponents or powers when we're dividing power numbers? 5 to the fifth power can be written as 5 times 5 times 5 times 5 times 5. The 5 to the second power can be written as 5 times 5. We can cancel out the ones that will turn into 1 whole. 5 divided by 5 is just 1. Same thing with the next 5 and 5. 5 divided by 5 is 1. So what is really left is 5 to the third power. So it's basically the same thing as just subtracting their powers. Now let's get the value of 5 to the third power. 125, which is our final answer. A to the second power divided by a to the first power. Subtract their exponents or powers. Therefore, it's a to the first power. Y to the sixth power divided by y to the fourth power x. Both x's on the top and at the bottom have the first power. Subtract their powers, then it's going to be x to the 0 power. And you know that x divided by x, or any number divided by itself, will just turn into 1. So anything that has a 0 power will just be equal to 1 whole. Don't forget that, okay? Now we have the y to the 6th divided by y to the 4th. Subtract their powers. Therefore, our final answer is just y to the second power. 2a to the second power, b to the third power divided by a, close parenthesis, to the third power. Since everything inside the parenthesis is raised to the third power outside, so you have to multiply each power by the third power. So on the top, we have 2 to the third power, a to the sixth power, b to the ninth power. And at the bottom, we have a to the third power. Let's further simplify. 2 to the third power is 8. A to the sixth power divided by a to the third power, subtract their exponents or powers. A to the third power, and it stays on top of our fraction. There is no other variable like b, so b to the ninth power will stay as is. Nothing is left at the bottom but 1, so our final answer is 8a to the third power, b to the ninth power. Okay, so like what we said earlier, anything that is raised to the 0 power will always equal to 1. So, for example, a negative 5 or negative 0.5 to the 0 power will be equal to 1. And that's what we call the zero exponent. Now let's talk about the negative exponent property. So if the power is a negative power, you have to place it under the fraction as one of the denominators. So you can write the fraction with a positive power. Just like this 6 to the negative third. So you can avoid the negative power, place that 6 at the bottom of a fraction as a denominator with a positive third power. On the top will be 1 whole. So what do you think of n to the negative fifth? Right, 1 divided by n to the fifth. And the a to the negative first power? Correct. And what if your denominator has a negative exponent? Then you just have to put it on top of the fraction as a numerator or one of the numerators. So you can write it with a positive exponent or power. 3 divided by x to the negative fifth power. We have to write the x to the negative fifth power on top of our fraction, so it can be written with a positive power. 8b divided by 2b to the negative power. Remember, we subtract powers when we're dividing power numbers. And that power at the bottom of the b, which is negative 5, will become positive because it's the same thing as 1 minus a negative 5. Our final answer is 4b to the sixth power. Okay, let's simplify 4a to the negative third power, b to the sixth power, divided by 16a squared, b to the sixth power, c to the negative fifth power. Let's do the coefficients first. 4 divided by 16. A to the third power divided by a to the second power. Subtract their exponents. They are the same sign, so we have to add. But since the power or exponent is a negative 5, so we have to put it at the bottom of our fraction as one of the denominators. So we can write it with a positive power, just like what the property says about negative exponents. Now let's do divide the b to the sixth power divided by b to the sixth power. Subtract their exponents. That's going to be 0. b with the 0 power is just the same thing as just 1 whole, so we'll have to just erase it. C to the negative fifth power is here at the bottom of our fraction, but it has negative power. So remember, if it has a negative power and it's at the bottom, you can go ahead and place it on top of the fraction, so you can write the power as positive. So from here to here at the top. So our final answer is c to the fifth power divided by 4a to the fifth power. Let's look at another example. 2 to the second power divided by 2 to the negative third power. You have to place that bottom number 2 to the negative third power on the top, so the power will just be a positive. So it's just going to be the same thing when I subtract them. It will turn into an addition. So our final answer is 2 to the fifth power. Next example, number 3, p to the negative 8th power divided by p to the third power. Here you can choose to subtract first their powers. A negative 8 minus 3 will give you a negative 11 power, which you will have to place under your fraction anyway, so you can have it as a positive power. Or you can go ahead and place that p to the negative 8th power under your fraction, and then multiply it with the p to the third power, so add their exponents. So our final answer is 1 divided by p to the 11th power. b to the negative 4th power divided by b to the negative 5th power. Subtract their exponents. And you know, minus negative 5 is the same thing as just plus 5. So b to the negative 4 plus 5 is going to be b to the positive first power, which will be our final answer on number 4. Our last example, a squared b to the third power, close parenthesis, raised to the second power, divided by ab, close parenthesis, raised to the negative second power. In this case, everything is raised to the second power on our numerator, so you have to multiply each power by the power outside. Same thing at the denominator, you have to multiply each power by the negative 2 power. Remember, parentheses between powers means you multiply their powers. So a squared times that second power, so 2 times 2 is equal to a to the fourth power. B to the third power times 2 is going to be b to the sixth power. At the bottom, a to the first power times negative 2 power will give you a negative second power. b with the first power times that negative 2 power will be negative 2. Now let's further simplify. A to the fourth power divided by a to the negative second power. Let's subtract their exponents. 4 minus negative 2. And you know, a minus negative 2 will mean also plus 2. So the power of our a is sixth power. Let's do the b. B to the sixth power divided by b to the negative second power. Let's subtract their exponents. 6 minus a negative 2. You know, minus negative 2 is also plus 2. So final power for our b is b to the 8th power. So our final answer is a to the 6th, b to the 8th, with a 1 at the bottom, or just mainly a to the 6th, b to the 8th. Let's have more examples and apply the rules in division properties of exponents. 2 to the second power divided by 2 to the negative third power. Let's subtract their exponents or powers. So 2 minus a negative 3 is the same thing as plus 3. So our numerator 2 will have a fifth power. Since our final answer is 2 to the fifth power with a positive exponent, so it stays on top of our fraction. So at the bottom will be 1, but that's going to be the same thing as 2 to the fifth power. So this is our final answer. B to the negative fourth power divided by b to the negative fifth power. Subtract their exponents or power. A negative 4 plus 5 will give you a positive first power. Since it's a positive first power, our final answer is just b. X to the fourth power, y to the 0 power divided by x to the negative second power. You know, anything with a power of 0 will just turn into one whole. Now let's subtract the powers of x. Or in this case, just add them, because if you place this x to the negative second power on top, it's just going to turn into a positive. Or if I apply the rules in adding integers, 4 minus negative 2, that's going to be the same as plus 2. So the power of x will be 4 plus 2 is 6, and it's positive, so this is our final answer. M to the negative third power, t to the negative fifth power, divided by m to the second power, t to the third power, close parenthesis, everything is raised to negative 1 power. Let's multiply first each power at the bottom by a negative 1 power. So second power times a negative 1 power will give us a negative 2 power for the m. And then t to the third power times that negative 1 will give us a negative 3 power for the letter t. Now let's do divide and apply the division properties of exponents. Let's do m to the negative third power divided by m to the negative second power. So negative 3 minus a negative 2 is the same thing as plus 2. And negative 3 plus 2 will mean a negative 1 first power. Since m has a negative power of 1, we have to write it at the bottom of our fraction as one of the denominators. So we can have a positive exponent for m. T to the negative fifth power divided by t to the negative third power. Let's subtract their exponents. Negative 5 minus a negative 3 is the same thing as plus 3. negative 5 plus 3 is going to be subtracted because they're different signs, and it's going to be a negative 2 power for t. And since it's a negative power, we have to place it under our fraction as one of the denominators. So we can write it with a positive power of 2. Now on the top, of course, is 1. And this will be our final answer. Now go ahead and do the rest of this page and apply the rules correctly. Good luck on your homework. Remember, practice makes perfect.